Welcome to a new test and teardown video. This one is another IMPO school laboratory electronics is what they make. And this is of course a high voltage DC supply. There is no name or number other than that. And I guess it's 0 to 6 kilovolts DC, because we see plus and minus here. High tension. Oi, oi, oi. And there's, no other names or marks or anything on this unit. This feels like it could be one of those Vario transformers, but it feels a little bit weird anyway. Look at that. So those are the mains voltage install blanks, and then they just drilled a hole and put in the high voltage bananas. And this is actually not a dumb idea, because this type of plastic here is very well for high voltage, a super good isolation, and it's also a fire retardant and very, very good and safe to use for high voltages. So yeah, why not? I think I need to open this before I plug it in, because this could potentially be a little bit dangerous and stuff. So I like to see what is inside before I plug it in. That was a very big surprise to see this unit inside. It is very different from what I guessed. That is actually really nice design with the banana plugs. So far so good. So that will be an output current limit board. The high power resistors here, that will be 200 kilo ohms each. So what, that's 1.2 mega ohm in the positive and 1.2 mega ohm in the negative. So it's symmetric, so that's quite nice. And then the high voltage goes to a rectifier and capacitor board. The rectifier is actually a bridge rectifier, and it's connected directly to a big high voltage transformer. So this one does indeed deliver all the high voltage directly. There isn't any doublers, triplers, or any other fancy smancy things. And this is a 220 volt type. So this is the mains input. Let's follow that wire. It goes to a voltage divider. Really? So how can that be accurate? If you look at the two big fat wires here to the right, that is the output. So at the moment, as you see the pot here, that is to the low, because now the transformer input is shorted. So in this case, an idle power is going through the resistors. And this pot is 2 kilo. Or is it 0.2 kilo? I think it is 2 kilo, right? And then there's another current limiting resistor of 220 ohms. So that will be my maximum. Then I have a full AC voltage to the transformer via a 220 kilo ohm, and then a load on the input of 2 kilo ohms. So that is the input circuitry to the transformer. So let's look a little bit on the rectifier board. There's a little bit of information here. It says high voltage power supply, 0 to 6 kilovolts, blah, 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 blah. And all those capacitors, they're in series, and each of them got an individual 1 mega ohm bleeder resistor. So the voltage will be spread out evenly in case every capacitor is working, obviously. And this is the negative side of the capacitor bank, and it is connected to the negative side of the bridge, and then out to the current limiter board. But look at that little detail here, what I saw. What do you think about this soldering? I mean, oops. Isn't that a little bit embarrassing? But it didn't fall out. Well, come on, somebody forgot to solder this. This is not good enough. And how can you assemble this? And first you make the board, and then you put it in the case, then you attach the wire here. I mean, you need to have a little bit of, you know, understanding of quality. This is not quality, isn't it? So what kind of a kit assembled this at a factory? I don't know. Well, that is not a good sign of their education level or understanding of what is good and bad. So I think I will try and power this up now, really slow and carefully, and see if I got equal voltages on all the capacitors, because otherwise I could very easily create a fatal problem here with shorted capacitors or something like that. So each capacitor here can do 450 volts, so that means I will just crank up the voltage to 450 volts total voltage on this point, and then I will measure if I got exactly the same voltage on all capacitors before I proceed to maximum voltage. I cranked up this pot to maximum. I'm measuring DC on the rectifier. We got 442. It varies a little bit, but it's just before I had 450. And so this is my DC voltage, and look at that, 17 AC input. So that means 17 divided up to what we have, 230 volts. So that is 13.5 times, right? Multiplied by 450, so that is a little bit more than 6,000 volts. This thing can potentially create. So that means the scale here on the front panel is not lying. Okay, so we need to be very careful when we're playing around with this monster. So let's try and measure the voltage over the capacitors. I still got my 17 volts of input, and let's start with the total just to verify. See, I got my 450. So that will be the first capacitor. So they are in series like this, up and down, up and down. So let's measure the first capacitor like that. Okay, 23. So that is, 23. So let's take the next one. Okay, 37. Oh, can I have my hands like this? So now I need to remove, swap plus and minus. 50 volts. 47. And then we go this way. Oops. 5. 32. And 16. 7. So, I mean, there's no need to continue with all this measurements. All the capacitors, they need to be changed. See, the voltage is between what, 50 and 5. So yeah, capacitors are completely defect. So this was really a good idea to start with a low voltage, low enough for the each and every one of the capacitors could handle this voltage. So I didn't blow up anything. If I crank up the voltage now to its full potential, some of the capacitors will completely over voltage and blow up in my face. So this is a very bad idea. So definitely we need to remove all the capacitors before we can proceed with this project. So so far so good. Now all the capacitors they are out. That was actually quite easy. I added a little bit of notes here, so I'm not going to screw this up when I get some new capacitors. By the way, look what I found. This is a little bit funny because they wrote 1375. Of course it's 1975, but still funny, isn't it? So this is from 75. So it's quite old. Maybe it's not that bad actually to have leaky capacitors. When you think about it, it's 45 years old or something. Okay, let's look at the rectifier diodes. BY176. Definitely some super nice high voltage diodes. And with all the capacitors out, I did double check all the resistors, and they're exactly 1 mega ohm each. So it was definitely the capacitors that was leaky. Here is the BY176 diode, and as we see here in the spec sheet, it's 15 kilovolts, so that's perfectly fine. Constant current of 2.5 milliamps and a short-term peak pulse 250 milliamp. And now it all makes a lot of sense because the transformer secondary winding is 25 kilo ohms and 6,000 volts. So that will be the 250 milliamp peak charge current you could possibly pull out of this system no matter what, right? Obviously this is far from possible due to the primary side resistor, and the 2.5 milliamp constant average output current is due to the current limiting resistors of 2.4 mega ohms on the output, and that gives 2.5 milliamps at 6,000 volts. I finally got all the capacitors needed for this project, so now I can continue restoring this really cool high voltage power supply. All I need to do is mount all those capacitors in here, and then we're good to go. New capacitors in, and I'm starting to measure the voltages and all that, but then it smells a little bit weird here. So look at the temperatures. Oy, 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 oy. 130 degrees, and I just turned this on. Those resistors are just way too hot. What the heck is going on here? And none of the resistors, capacitors, anything here is hot. This is not good. What is going on? I gotta turn this off. I disconnected the mains input for the transformer just to make it safe to debug this system here. So now it's actually turning on. Look, oh, now it's turning off. So that switch is just absolutely unstable. Look at that. And now it's off. Okay. I need to service that 23 watts of idle power is burned into this primary side resistor. That is a voltage divider on mains voltage that goes to the transformer. That is not good. This is definitely not ready for 23 watts. And it gets very, very warm. Look at that. Immediately. That is definitely the most stupid and wrong design. I mean, we are forced to solve this somehow, right? Now I've been googling a little bit around, and it's actually not that bad. When it comes to this, it's 230 volts RMS, right? And then we got 2K here and 220 here, so it's less than 3 watts in this 7 watts resistor, right? So that means 20 and some watts it is burned off in this. I mean, it looks a little bit less. It looks a little bit small for 20 some kind of watts, right? But they're actually rated for this, and they can handle quite a lot of crazy high temperatures. But I just don't really like this design. But this is not the same as it is a wrong design. I just recommend you don't run this for hours. Adjust the right voltages and do whatever you want, and then turn it on and off, so it's not powered on for more than just a few minutes, and then just turn it off here. So then you're gonna be fine. So what I did is I just got 18 volts of AC mains input, DC voltage here, and then I just measure the output voltage, 413. Alrighty then, and this is cranked up to maximum. So that means no matter what happens, my total voltage is less than what one capacitor can handle, right? So now I'm just measuring around all the voltages on all the individual capacitors, that they're exactly the same. And they're about 30 something volts, each of them, when I probe around here. And that means the voltage is equally divided between all the new capacitors. So that is a good thing. And that means now I dare to crank this up to its maximum potential. Yes, indeed. And yes, you are of course going to be here for the very first test live. It's more fun this way, isn't it? So this is my high voltage fluke probe. Nah, I was an idiot. Now mains is applied. And here we go. My 23 watts of idle. Let's crank up the juice. So that's about 3000. And look how accurate the readout is here. And that is really, really nice. What if I turn this off? How long is it going to stay dangerous? I mean, that is quite some time. That is 100 volts. Still enough to tickle a little bit, right? So let's see if it can handle it. Yes, that is good. Of course it can handle that. 4000. Wow, nice. 5. Now my mains power is 28 watts. I hear something I should not hear. I hear something. Listen. This is not good. It is about to kick over. This is not so good. I'll have to investigate. Using a thermal camera, you can actually, maybe you can feel this in my voice there. I was getting like a little bit tense. Ooh, because when you got this kind of capacitance here, you don't want to have an arc over on the other side of the resistors. I mean, it's perfectly all right here because it's super duper current limited. But you don't want to have it on the capacitor side because it's gonna say bang kaboom really, really loud. So, ay, ay, ay. I've just been running this at full 6,000 volts for a few seconds. I can feel that you can see this. All the 1 mega ohm resistors here, they're actually quite warm. And it started to say this funny sounds. And that is obviously because we are going to get a lot of this is nasty stuff, but yeah. We are going to get a little bit of emission from all the high voltage points here, right? And that is something you can hear. So it sounds like this tickly sound. And there's also the transformer itself is actually humming quite a lot. So that added to this sparky kind of sound from the high voltage components just scared me a little bit. I'm just maybe getting sensitive on my old days. So sorry about that, but or getting a little bit, I don't know, safer, more careful. Maybe it's just because I know what kind of nastiness this can do. But it's actually quite alright. This one can indeed run at full 6,000 volts for more than 25 seconds. And that's perfectly alright. You don't need to perform long-term experiments with this. Maybe I would recommend changing this resistor divider to one of those tiny little variable transformers you can get. There's actually plenty of space for the tiny little vario trafos, or whatever you want to call them. They're super nice devices, and then you don't have this idle power problem, and then you can run this unit all day long if you want to do that. Yeah, I feel this is going to be a real shitty and disappointment of a video if you don't see a little tiny spark before we call this done deal. So let's play. This tiny little spark is all you're gonna get. Ooh, aren't you impressed? This is what current limit can do for you. Oh, the smell is intense. Yeah, that's what it is. If you get if you put a capacitor on the output side here, then it's going to be a lot more fun. I'll try and see if I can focus lock. Yes, I could. Here you go. Beautiful.